For as long as I've known how to solve one of these, I've always had people asking me how I actually do it. So, if you're one of those people who's asked me, Chris, how on earth do you solve Rubik's Cube? Here's a video teaching you how. And I know there are loads and loads of YouTube videos out there for beginners, although in my experience, not all of them are as beginner friendly as they should be, because I think if you've been doing something for long enough, you forget what it's like to actually be a beginner. For example, I remember the first time someone tried teaching me how to solve a cube, and they said things like, oh, this algorithm's easy. You do R, U, R prime, U prime, R prime, F, R2, and I'm sat there thinking, wait, what is a prime? What are R2s and things like that? So I'm deliberately making this video as beginner friendly as possible, and it will probably use language that's going to make professional YouTubers completely cringe in frustration, but I'm honestly just trying to replicate how it felt for me when I was learning for the first time how to solve one of these. But before we begin, we'll start with a couple of very important points. Number one, you do not need to be clever to know how to solve a Rubik's Cube. There is this stereotype that goes around that only the really, really clever people know how to solve a cube, only the real geeks and nerds know how to solve it, but that's actually completely wrong. Really, all you need to, in order to solve one of these, is have a half-decent memory and be half-decent at pattern spotting, and put the time and the effort in, and that is basically it. Number two, as I always say when I'm teaching lessons, whatever works for you, works for you. I'm going to teach you a bunch of things that helped me when I was learning how to solve one of these for the first time. If it doesn't quite work for you, then you do not have to follow it. Your brain, your methods. Number three, this will take time. It might be a good idea for you to bookmark this video or add it to your watch later list, because you will end up rewatching and rewatching various bits of it. It took me weeks to learn how to solve a Rubik's Cube, but I got there. My record is now 16 seconds, but it does take a while to get there. And speaking of which, number four is whatever you achieve, be proud of it. If you manage to do the first two layers, then be proud of that. If you manage to solve it, but it takes you 20 minutes, then be proud of that. My very first time ever unassisted was 5 minutes 49 seconds, and even now I can solve it in 16 seconds, I'm still very proud of the day when I solved it in 5 minutes 49. Number five, and now we're getting to the really practical ones. As tempting as it is to keep rolling the cube around in your hands, please don't. Always have the same one on top so that you can actually see what you're doing. And number six, also a practical one, the centres never move. Well, in the literal sense, you can if you do things like that, but what I mean is they never move in relation to each other. The white square is always opposite to the yellow square. The blue and the green are always opposites, the red and the orange are always opposites, and no matter what you do to the cube, you will always have these being opposite to each other. And trust me, that will be useful when I start teaching you. And the last thing to tell you is that once you do learn how to solve a Rubik's Cube, there are loads and loads of different ways of getting faster. A lot of cubing involves these things called algorithms, which are basically moves in the order in which you make them. This is the R, U, R prime, and so on that I was talking about earlier. And there are hundreds of different algorithms that you can learn. You only need to learn about 5 to learn how to solve a cube, and I'll be teaching those 5 in this video, but there's so much more if you do want it. So I'll start off by saying that one popular misconception is that you need to solve this face by face, like solve the white side, then solve the orange side, then solve the green side. Don't do that, it won't work. What you actually do is you solve it layer by layer. There are a load of different ways of solving a Rubik's Cube, but the most popular one, and the one that I use, is called CFOP. Not that you need to know this, but that stands for cross, first 2 layers, orient the last layer, permute the last layer. But in terms of what it actually looks like, it basically looks like this. First you do the white cross, then you do the white corners, and that's the first layer done. Then you do these 4 here, and that solves the second layer. Then you do the yellow cross on the top, because remember, yellow is the opposite to white. Then you do the yellow corners as well, and the only thing left to do is get these in the right order. You start off by aligning the corners, and then all you need to do is swap these around, and then you're done. And while I'm at it, that notation, the R's and the U's and the B primes and everything else, if you want to get really good, then eventually you're going to have to learn it. But if you just want to learn how to solve a cube, then you don't. Much in the same way as you don't have to learn how to write before you can literally speak a sentence. You don't have to learn Rubik's Cube notation in order to just make the moves and solve the cube. Now first off, doing the white cross. This can be either the easiest part or the hardest part, really depending on how your brain works. If you have a brain like mine which largely relies on memory, then this is probably the hardest part. But if you can do things intuitively and work things out for yourself, then you'll probably find this the easiest bit. But you need this, this, and this to be white. It does not matter what happens to the corners. These can be white or non-white. It really just does not matter. The important thing is that you get these bits to turn white. Now you'd think this will be enough, but it's actually not quite right. Remember what I said earlier about how the centers never move? Well, what that means is the only piece that can possibly go here, by coincidence it's there now, is the one that is yellow there and green there. No other piece can correctly go between the yellow center and the green center. The only piece that can go here is the one that is blue and red, because nothing else can go between the blue center and the red center. What that means is you don't just need to get the white cross, you need to make sure that it lines up with the centers as well. So the red one needs to be there, the green one needs to be there, the orange one needs to be there, and the blue one needs to be there. But if you find that it's not quite worked out, that's completely fine. Just turn them 180 degrees, move them along. There you go, they're lined up now, so just bring it to the top. And then bring this one along as well. Now, it is completely fine to take several minutes about this because, like I said, it's one of those things that you can't just put down to memory. You've got to work out from experience what goes where when you move each face of the cube. By the way, if any of this looks demanding, I can assure you it's a demand that you can actually reach. A big bunch of the people who ask me how to solve a Rubik's Cube are young people who can actually solve one face of it. In fact, there's quite a few people I know who can solve one face of a 5x5x5 Rubik's Cube. So in my opinion, if you can do that, you can definitely do even the trickiest bits of solving a 3x3x3. Oh, by the way, something important. For the first bit, we have the white square on top so we can get the white cross. Once you've done the white cross, turn it over and you do the rest of the cube with the yellow one on top. Next up, we've got solving the corners, and just like it was with the edge pieces, there's only one piece on the whole cube that can... I'll try it again. There's only one piece on the whole cube that can go between the red center, the green center, and the white center. Yep, you guessed it. It's the red, white, and green one. So we need to get that down there. Except we can't really just push it down there because even though it's in the right place, it pushes the one out that's already there. So what we need to do is find a way of getting that one down there without moving that one. Well, we can't do that in the literal sense, but what we can do is push it out the way, bring this one up to meet it, and then once it's lined up there you go. And there you go, you've done a corner. Let's try again with this one here. We want to get that down there, so move it out the way, bring this up, bring that in. Wait, hang on, nope, that didn't work. Why didn't it work? Well, because you need to make sure that you push them the right way. So whichever face the white one is on, push it further in that direction, because that means no matter what happens to this, it's not going to affect that piece there. What we're trying to do is get this one out of the way. So once this one's nicely out of the way, bring that up, push it back, bring it down. Now it does get a bit tricky if the white piece is on the top, but here's what you do with that. You keep it on top, you push it up, rotate the top twice, then bring that back down. And then suddenly it's exactly where it needs to be to do the other thing. Push it away, bring it up, match it up, bring it down. There is actually a quicker way of doing this, but it might be less easy for beginners to understand. Again, this depends entirely on how your brain works, so if this doesn't make sense, then forget about it. If it makes more sense than the one I just described, then do this one instead. But keeping the white piece there, flip it that way, so that one's up, push that to match it, and then bring it down. So now the whole of the bottom layer of the cube is done, and now we need to focus on this one, this one, this one, and this one. We only need to do these four, and then we've solved the second layer as well. Now this is where algorithms come in, and algorithms sounds like a really scary word because it sounds all mathematical and stuff, but really it's just moves and the order you do them, that's it. For example, the only piece that can go here, as I've said before, is the one that is red and green. That's the only piece that can go between the red and the green centers. So basically this one here. Now there's an algorithm, or a sequence of moves, which puts this one down there without bothering any of those. What it is this. Away, bring up, reverse the two you just did. Further, flip back, reverse the two you just did. So the piece that was there is now there, and all of this is still the same. Now obviously I'm going to go through that a few more times, so let's take this as an example. the piece that needs to go there is the orange and the blue piece. And since that bit is orange, we'll put it above the orange because these two colours need to match for this algorithm to work. So once that's above where it needs to be, it's away, bring up, reverse the two you just did, too far, flip back, reverse the two you just did. Now those words that I was saying just now, they're my personal way of remembering this algorithm. If you can find a different way that works for you, then use that instead. Alright, so let's do this one, putting it there. You turn the top away from where it needs to go, then you bring up where you want it, and then you do the reverse of the two you just did. Notice how you've got this nice column here. Then you push it too far. The reason I say too far is because we want it there. Let's push it a bit too far. Then we flip the front back, and guess what happens now? Reverse the two moves we just did, and then it's in. Now if you've watched that and it doesn't make sense, that's completely fine because, like I said, it will take time for this to make sense. The only tricky one is, what if you have one in but it's the other way around? Well, what you do is put something else in its place. Let's put that one there. And then, once it's out, put that one there. And there you go, you've now done the first two layers. By the way, when I'm teaching this face-to-face, this is usually where I say, that's enough for day one. I mean, if you can memorise the whole of the bottom layer and 5 algorithms in the same day, then that's great, do it. But if day one finishes and all you can do is the first 2 layers, then that's actually pretty good. So the next thing you're aiming for is the yellow cross. And as said before, it does not matter about the corners. They can be whatever colour you want, including yellow. The important thing is you get this set up. Now, by the time you've done the first 2 layers, there are 4 possibilities for what can be on the top. There could be this, in which case, well done, you've already solved it by accident. Let's move on to the corners. But if you don't have the cross already solved, you could either have one bar going across, and again, you can ignore the corners, or you could have them at a right angle here, or you could have none of them solved whatsoever. And the solution to each of these 3 is actually kind of similar, whichever position you're in. Now, the way of solving these involves turning the front, doing a bunch of stuff, and then turning the front backwards. When I was a beginner, I used to call this the unlock-lock method, because it felt like I was unlocking it, doing a bunch of stuff, and then locking it again. But again, whichever way you want to use to memorise these things, then yeah, do them. Your brain, your methods. But the unlock-lock method basically involves turning the front clockwise, right side, top side, reverse of the 2 you just did, and then put this back in place. Now, if you had a bar going across at the start of that, you will definitely have all 4 of them at the end of it. Mathematically, there's nothing else that can happen. Now, if you have them at a right angle, then what you do is you put them at 9 o'clock, as in making this look like it's 9 o'clock. And then you do something really similar. It's basically the same thing, but the moves are slightly in a different order. Turn the front, and then you do the top bit first, then the right, then the reverse of the 2 you just did, then you put it back. And then you have all 4 of the yellow cross pieces. By the way, if you accidentally do the wrong one, for example this, that's fine, just do exactly the same one again, and it will end up just getting there anyway. And if you only started with the dot, just do one of each. And then put this at 9 o'clock. By the way, you may notice that when I was teaching the beginner's method, I was doing this with the front side, and when I do it myself, I just do this. You'll end up learning as you get better things called finger tricks, which basically involve the most efficient ways of moving different things with your fingers. But if you're just learning how to solve a Rubik's Cube for the first time, those things don't really matter. Okay, it's time to sort out the yellow corners, and the algorithm for this was always my favourite while I was learning how to solve the cube. Its proper name is the Sune, sometimes mispronounced Soon, but again, you don't really need to know that. I just used to call it the up twist, down twist, because it literally goes up, twist, down, twist, up, twist, twist, down. Now, it used to be my favourite because it's just so satisfying to do with the fingers. Up, twist, down, twist, up, twist, twist, down. And it's a good job because you might have to do this a bunch of times before getting it right. Because if you just happen to be in this position with what I used to call the fish, because this kind of looks like a fish, and a yellow bit here, then you know you're just about to solve it. Up, twist, down, twist, up, twist, twist, down. Now honestly, a bunch of this will be trial and error just until you get the fish shape. And once you get it, you'll either find a yellow bit there or a yellow bit there. If the yellow bit is there, then just do the algorithm once more and you've solved it. If it's there, you do the exact same algorithm but mirrored, so the other direction. So instead of turning this clockwise, you turn it anti-clockwise. And instead of doing stuff with the right hand side, you do stuff with the left hand side. So up, twist, down, twist, up, twist, twist, down. So the Rubik's Cube has more than 43 quintillion combinations to it, but once you've done the first 2 layers and you've done the yellow face, then there's only 19 of them left. Now, if you're lucky enough to have something that looks like this, where if you rotate it, then all the corners are in the right place, then you can skip this next. What's likely to happen most of the time is that they don't line up nice and neatly, but you do get a pair of what we call headlights at the back, where these two are the same colour. You'll also find a bunch of them where all 3 of these are the same colour, just treat those as your headlights. But what you do is you have them at the back, and then you do the second to last algorithm. Now, when I was learning the Rubik's Cube for the first time, my nickname for this was The Tricky One. I wonder if you can guess why. But don't let that put you off, you can memorise it. But it goes like this. This one goes down, you turn the front side so it goes down further, and then you turn it down once more. Once you got that, you turn the back twice. That should give you a nice Tetris shape at the back. Then you do what I used to call the retreat, which is move this back to where it was, move the front back to where it was, and then you push it back down a bit further, and there's your Tetris shape again. Turn the back twice, turn the right side twice, and then there you go. You have all the corners sorted. So just once more, make sure your headlights are at the back, whether it's just these 2 the same colour or all 3 of them the same colour, and then down, front, down, turn the back twice so you got the Tetris piece, and then what I used to call the retreat, which is pushing this back and pushing that back, and then you push it forward once more, and once you've got the Tetris piece on the back, turn that twice, and then you've got your corners. Now, if you come this far, there's only one more algorithm you need to do, and there are 3 different positions you could find yourself in. You could either find one of the faces solved, and then that one needs to go there, that one needs to go there, that one needs to go there. You could have the same but the other way around, so one face being solved, but that one needs to go there, that needs to go there, that needs to go there. Or you could find that none of the sides are complete, and that's fine, you just do the following algorithm twice instead of once. So what you do is you line up the one that's finished, if you have one, and you keep that at the back. Then you look at the front and you think, does this need to go left or does it need to go right? This one clearly needs to go left, so let's remember that. And I call this algorithm the downy-uppy, basically because it reminds me that I need to go down before I need to go up. Let me demonstrate. What you do, once you've memorised which way this needs to go, is you turn the front 180 degrees. You then turn left, and then both the sides down, 180 degrees, both sides up, hence downy-uppy. Then you turn it to the left once more, and there you go, you're done. And if this one needs to go to the right instead of the left, you do basically exactly the same thing. You keep the completed one at the back, and then you turn the front 180 degrees. You bring this to the right. Both sides down, twist the front, both sides up. Then you turn it to the right once more, and it's complete. Now if you have a situation where none of the sides are complete, like I said, just do the algorithm twice. And the first time you do it, it really doesn't matter whether you go left or right. So that's it for this video. I hope you found it helpful, and if it takes you several weeks to learn how to do this, that's completely fine because that's how long it took me. Finally, there are a big bunch of people I know who say it will really make them cringe if I finish by saying smash that like button. So no, don't smash that like button, just press it like a regular civilised human being, and I'll see you next time.